Hi everyone, this is a new tutorial series where I'm going to follow up a series of videos to basically get you into a simple full game rather than just doing one piece of functionality. So in the series we're going to create a space shooter in Unity. We're going to create a player ship. We're going to create enemy ships. The player and the enemy are both going to have health. So they're going to take damage. We're going to create some cool scripts for camera following, some waypoints, patrolling behavior for the AI, and enemy seeking behavior, so they kind of seek out a target like another space station that you'd have to defend, or the player themselves. So basically everything you need to kind of have an entire little space shooter game here. So I'm using Unity, and this is Unity 4.34. It is the Pro version for, for Windows, not for the mobile. That's why the layout looks dark. I am using the 2x3 layout, and then in my project window, I go in here and I turn off this two-column layout. Just too much for me to look at. And also, if the console down here is missing, just go down here, Windows, Console, and then I undock by just like dragging this game window out. And for this demo, we're not going to make any builds, so we're on the default PC. We're just going to look at things in the editor. So we're empty right now, and we have a main camera in here. Our project's empty. So what we want to put in first in this first tutorial, all we're really going to do is just set up a cool camera, a third-person following camera that's got really nice rotation and positional damping on it. So it's not like one of those cruddy-looking third-person follow cameras. It actually smoothly, cinematically follows. And there's no issues if this ship goes upside down or barrel rolls or other crazy things. So we're going to set up that camera follow script, and we're going to set up the space skybox, which I've already provided. You want to take a minute and kind of pause this video and look down in the video description. You'll see a Dropbox link in there. It'll download a Unity package file, which you will go Assets, Import Package, Custom Package, and then just look where you downloaded it. It'll be called Skybox. Click Open. It has all the textures, import, and this is what you'll download off the link I'm providing in the video description. So there we go. We got a folder called Art Assets now. Mine automatically populated it under Edit, Render Settings. In this project, I already had it set. But basically, this is how it would come in. You want to Shift Select all your textures, and you just want to make sure that they're set to clamp. By default, they're set to repeat, but I think because I made this package, they came in with the settings of clamp. Just make sure they're set to that. Basically, there's no UV repeating of the texture back and forth, and clamping will help reduce any kind of seam issues. And then it came in with the Space Skybox texture, which is just your standard render effects Skybox Unity material for skyboxes, and everything's assigned where it should be. So there's some art assets. To get it to show up in your scene like we did when I initially opened it, we go Edit, Render Settings, go over here to Skybox Material, take a look, just assign it to that. I'm going to go under Gizmos here and hide the grid. And you'll see it's pretty cool. It's seamless, and it just looks like you're in some kind of nebula of outer space. It's very cool. Man, all royalty free and everything. I put no licensing restrictions on it for commercial or free use or anything, commercial or free projects, non-commercial. So our skybox is in there. Let's get into getting a script on the camera to control it. I want to keep all of the videos in this series probably 20 to 25 minutes or less if I can. So this is kind of a rapid learning sequence, and you end up with a full project in just a couple of hours. So let's just call this one Player Cam. You can name it anything you want. I'm going to turn the grid back on so you can kind of see where things in the world are. I'm going to turn the gizmos way down because I don't like the giant camera gizmo. So right now, our camera is at 0, 0, 0. So if we look here in our world, in our grid, the root of the camera is sitting right here at the origin. It's transform and position set to 0. So what we want to do is we want to make a script that'll make this camera follow a player. Now in the tutorial series part 2 we're going to create an actual playable player. For right now we're just going to go game object, create other, a cube. Its position is all jacked by default, so we're going to click this little gear, reset position. Okay, that's going to represent our player. So let's just name it player. And this is just going to roughly represent the object that we're going to make the camera follow in this script. Let's back our camera up a little. Let's just set that to like -5. So now our camera in Z, down the Z axis, this blue one, is back away from the player, and the player is at origin, which is ideal. So now we need our script. I'm going to move this window out of the way, down here. We're going to go in our project window in this empty space, and I'm going to right mouse button and hit create folder. I'm going to call it scripts. I'm going to right click on it again, and I'm going to go create C# script, and we'll call it camera script. Impossible to decipher what this could mean. What is this camera script for? God only knows. I don't know. So I double clicked it. It's opening up this awful mono development. And if you work with mono development long enough, you'll enjoy some of the nice things that it does, like crashing mid scripts, or I don't know, it's crazy. Anyway, let's select our player camera object, because this is really the object that we want to control. We want to allow it to follow the player. So let's just drag with left mouse the camera script. So now this camera has a bunch of components. It has a transform component, so it is a transform, but it's also a camera because it has a camera component. It's also a layer for GUI and flares. It also has an audio listener, and now it also has a component of a camera script that will control it. So I'm going to double click it, and this is our default C# script. Camera script, which is the public class name right here, needs to match this file name here. This matches this. If they don't, you'll get weird errors about the class name not matching the script name and blah blah blah. Sometimes that's a common thing that people overlook. So I'm going to remove this. This is called code commenting. It's light gray. If I removed one of these forward slashes and we hit save, we got a bunch of weird errors, unexpected symbols. Okay, it's because that was commented out. And what that is that just tells you what this function or variable or this part of the script is going to do. And you do it by 2 forward slashes and then typing whatever you want. Everything that's on this same line will be commented, and when I type down here, it's not. Give it a few more forward slashes. You get the idea. This is Unity putting in some comments just to let you know, well, the update function here, a method is called once per frame. This is used for initialization. We want to do something here which is declaring some variables. And what we need this camera to be aware of is what is the object we're going to follow? What is its target? Okay? So let's start declaring our first variable here, which is going to be the target thing that the camera is going to follow. We're going to start with public. We're going to go transform, and then we're going to call it, not target, target. So what's going on here is this is a variable. This is the variable name, the last thing. We called it target because that's pretty straightforward, but we could have called it player target or something like that to be even more specific. It's a type of transform. That's what this player target is going to be. It is a transform, and it's public, which means in our Unity inspector, as soon as it compiles, you'll actually see it show up. There it is. There's a slot, and it's saying, here it is, it's a target, none, type of transform. So basically, both of these things have a transform component. So really, you could drag the camera's own transform on it. You could grab the player's transform on it. But if I was to go game object, create other, and spotlight, and I want to drag, well, that's a bad example, because actually the spotlight has a transform on it. Wow, what a way to fail at my example, because I'm trying to find an object in here that wouldn't have a transform. Wind zone? No, it is a transform too. Golly. Well, here, this is a good way to demonstrate. Instead of being a type of transform, let's make it a type of camera. This is better. Do you know why? Because only some things have a camera component, so it's saying, I want a camera. So player camera would drag into itself, though we'd never have the camera follow itself. But the player has no camera on it, so could it be dragged in? Nope. Will not let us drag it in or assign it because it says this type is a type for camera. That's the only thing we want in this slot. So without harping and going on and on, that's an explanation of how casting what the type of this variable is right here. Transform. It's a player target. It's the thing we want to follow. And we want to follow its transform, which is its X, its Y, its Z, basically where it is in the world, its world position. And lastly, it's public, which means it shows up right here. Makes a little bucket or a slot that you can drag into. Okay, so that's public. If you have like designers and things that are going to access your objects with scripts, and you don't want them, or there's a variable that you don't want anyone dragging anything into because you're going to like automatically or procedurally assign something, you don't want them touching, just write private, and it will disappear, just like a soldier in the Civil War. So it's gone. Okay, we want it public. We want to see it. Okay, so we have our target. Oh, that's a mono development thing. So we need another one. And this is going to be like, where do we want this distance of the camera to follow? Like how far behind and above the player do we want this camera? So we could say like we want it 2 up in Y and -5 units back in Z. So basically, that's what it would be behind the, of course with a little bit of rotation, but that's what would be behind the player. You see that, the transform position of it. Up 2 units in Y, behind 2 units in Z. Okay? So what we need for that is not a transform, though honestly a transform could work for this, but we want what's called a vector 3, which is 3 points in world space. Vector 3 is basically reference X, Y, and Z positions in 3D space. We're going to call this variable the distance. So we're saying show it in the inspector with public. It's a vector 3, so it's 3 points in space, and it's a distance. Okay, we're just going to hit save so you can see what a vector 3 looks like publicly in there. All right, type mismatch because it was camera before, and we had the camera assigned. Let's just put the transform in, and there we go, we're good. So there it is. You see, our distance looks just like the transform position X, Y, and Z up here. So this will let us set some positions for this transform. Pretty cool, huh? It starts 0, 0, 0, but we want to give it some default values. So instead of using a little semicolon in this line, let's say that this equals a new vector 3, a new set of points in 3D space. I'm going to go 0f, 5f, comma, -10f, and now. Okay. So what this says is this vector 3, this X, Y, and Z, which is going to be the distance, the position of the camera and distance behind the player. We're going to set this equal to some values up here right away. We're going to say in X, which is this, it's a value of 0. And the F means it's a float, which means it could be like 0.1, 0.2, 0.3. It could be like a decimal, floating decimal point number versus being like a whole number like 1, 2, 3, 4, 5, 6. It could be like 1.75, 1.20. So float, followed by the number, followed by the F. And then in Y, we say 5 units up in Y. And then in Z, we say 10 units back. So if we save it with that, we look, should get some default values in there. Let's remove it and reapply it. And then they show up, right? Didn't update there in real time, but there they are. The other important thing to know is these are values we've set in the script, but any values that you set here in the inspector are permanent. Well, not permanent, but they override the values in the script. Those are default to start with when you first assign the script. These values, if I hit play and then unhit play, they stay the same. I can actually right click on the script and go reset, right there, and it'll reset those back to, well, it should. Did it not? Yes. Okay. Reset those back to the 5 and the -10, and then it took away our assignment. So you can always reset it. Those will be the default values. We definitely don't want the player camera by default, if you forgot to set values by default, being at 0, 0, 0, and it would be inside the player, not like behind it. You can always change these. These values in the inspector will override the script and they will persist every time you hit play and go back. Your inspector values will stay the same. So we know our target. We know how far we want to be behind the target by the vector 3 distance. Now we need to think about, well, let's smoothly make that distance kind of interpolate by doing some damping, like smoothly damping the position. Like instead of teleporting from A to B, let's just like kind of smoothly in and out, and ease in and ease out. Some other artists use those terms, ease in and ease out, for animation and things like that. That's what we're going to do. So let's create another public, which means it's going to be in the inspector visible, and it's a float. We just talked about a float. Instead of a whole number, 1, 2, 3, 4, 5, or 6, which is called an int or an integer in C#, this is called a float, because this basically allows a long degree of numbers like this. You know, that's a floating number, whereas if it were declared an int or something, it could only be like this. We want a value that will allow us to be a huge range of values. So a floating value, public float, and we want to dampen the position. Okay, we're going to give it a default value of 2.0, 2f, 2 float. Okay. Now we also want to dampen the rotation too. So what I did there was I just select this whole line, Control C, Enter, Control V. Why waste your fingers on carpal tunnel, your wrists rather, when you can copy and paste? Okay, so we want to look at a value for damping and smoothing out the position for the camera and the rotation. Those are float values that are going to show up publicly. The last thing we want to do is we want to reference the, I'm in play mode. Okay, all right, there we go. Position damping showed up. Why did rotation rotate? Guess I didn't save it. Okay, and rotation dampening. And of course, if you were to set this to another value in here, it would override that. So the next variable that we're going to put in here is the last one. And that's going to be a reference to, because we have a reference to this transform for the player, but we don't have a reference to the transform on the camera. Now, since this camera script is on this camera transform, this script will automatically, when you hit play, would automatically assume that any kind of movement on the transform or anything done to it would be this transform. But during the, let's back up a sec here, void update, says it's called once per frame. This is run every single frame of your game. And you don't want the script every frame of your game to be constantly checking this camera here for its transform. So we're going to do what's called caching, and we're going to kind of store it up front so we can always access it, and we're going to catch it once. Once we catch it and put it in the bucket, this update here in the frame can use that one transform the entire time rather than checking every frame for it. So what we're going to do is we'll make this one a private, because we're just going to assign this to itself as a transform. So we don't want any artists or designers or anyone else plugging something manually into this. We're going to make it private. So if we hit Control S and save, you don't see it show up. It's not something we can adjust. We're not going to be dragging the player camera into its own transform slot. We're actually going to tell the script, look on this object that has the camera script on it, find its transform. Okay, very easy because the script is actually on this object. So what we're saying is hide it in the inspector. We want a value type of transform, that's the variable type, and we want it to be this transform of this object. So I'm going to remove some empty wasteful space. We're going to go and start. Start is not like update. It only runs one time. When you hit play in Unity, this script will run the start method. Once everything goes through that start method, that's it. It's not accessed or used anymore during the rest of the game. It's not pinged or anything. Some of the variables set in start will be used in update, but not used within start. So what we want to say is, let's take this variable for this transform, and let's just say it's equal to transform. Seems kind of silly, but let's use that code commenting too. 2 forward slashes. So let's say cache the transform component of this camera so it doesn't need to be looked up each frame, because it will be accessed every frame, which is fine, but we don't want the script looking for it. So that's done. As soon as the scene starts, you'll see something cool here. Alright, so I'm going to hit save, Control S, go back. It's private, so you don't see it. But let's make it public just to view it happening. And you're going to watch the script. It's empty, it's null, and we're going to watch the script grab it automatically. Boom. It grabbed player cam's transform and plugged it in. So that's exactly what that's doing. Okay? So let's get into the nitty-gritty, which is going to be the update. Okay? So Google is your friend. I see so many developers, young or old or whatever, and they on the forums and on the Facebook groups, they just don't use the Unity community or the forums to find things, but it's very easy. Just Google what you're looking for. We want to know about late update. Late update is called every frame after all update functions have been called. For example, a follow camera should always be implemented in late update because it tracks objects that would have moved inside of update. Okay. So basically what that's saying is use late update for things like involve the camera, because it's a function that occurs after fixed update, after update. So basically your ship would have rendered and moved and done all of that, and the physics would have happened, and then late update occurs. And since this camera's following, we want to make sure everything else like the movement and the physics has happened, and then the camera catches up and follows it after, not cameras moving before it. So instead of where it was update by default, we're going to use late update. And the first thing we want to do is that we're going to access this the player target, which I'm going to go back and we're just going to name target for simplicity. Okay. We're going to access this in late update, so it's going to look for it right away. So what we want to do is a check to make sure that it's there. Do we have a target in the scene? Is the target assigned to this script? So we're going to ask a question. We're going to use an if statement. We're going to say if the target Traget. What is wrong with me? If target, and then we're going to do some little brackets. Okay. Okay. So what this is doing in the code is it's saying if the target is null, which means this target value transform is empty. None. Nothing's in there. None means null. So if the target is null, return. And all return means is don't execute anything beyond inside of this late update. Go back up to the top. Start over. Check for a target. Is there no target? Return. Start back over. So it never gets down here to access the actual target, because there would be an error for accessing the target. This is also shorthand. This if exclamation point target really means if the target equals null. So we could type it like this. Okay? Same exact thing. It's just the if exclamation point target was programmer shorthand to save your hands from carpal tunnel again. Okay? But this is just saying if the target's null, return, don't do anything. It's a sanity check to make sure that this target's been assigned. But assuming it's passed that check and it's not null, which means there's something there, it's assigned, then let's do everything down here in outside of these brackets. Let's not return. Let's go down here to the rest of the function and do it. The first thing we want to do is set another variable inside here. We're going to do a vector, not 2, 3, and we're going to go wanted position. And this is going to be the position that we want in the 3 axes, vector 3, X, Y, and Z, 3 positions. What is the position we want for this camera to happen and update every single frame? Where do we want it to be? So we're going to say, well, let's even drag it. Let's take the target's position. I cannot type. Plus, let's use some little brackets here. Oh, I cannot type today. Target rotation times distance. Okay, and close it out with a semicolon. Alright, so what we're saying here is we need the 3 points in space, X, Y, and Z. We want them as our position for the camera, its wanted position. So we're going to say, well, the wanted position is equal to the position of our target, the player, plus that target's rotation, and then times how far away it is. How far is the camera from that player? That's our wanted position. Okay? So the next thing we're going to say is, well, what's the camera's actual current position? It's X, Y, and Z in world. It's vector 3. And so common sense says we will call it its current position. And we will say its current position will be equal to, and this is vector 3. This is fun, a lerp. I'll explain all this in just a minute. Just get it all typed out. This position, wanted position, position, damping, times time dot delta time. Fun! Okay, so we're going to say this is the position we kind of desire or want. This is in reality the actual camera's current position. A vector 3 lerp is saying what we're going to linearly interpolate between the values. Okay, let's look this up. I love Unity documentation. So there's vector 3 lerp. Linearly interpolates between 2 vectors. Interpolates between from and to by the fraction of t. Wow, sounds like some mathematics, and I'm an art guy. So let's just explain this in layman's terms. Vector 3s are basically this: X, Y, Z. It's up 2 units in Y, it's behind 2 units in Z. That's a vector 3. So let's say that the current position is a vector 3, set of 3 axes. Let's linearly interpolate between where the camera is to where it wants to be, where it is to where it wants to be, times the damping and delta time. We're not going to look up time delta time. Time delta time is just time every frame passes in your game. You add it for smoothing, and you add it for things that you need to track the value that occurs over time as time happens in your game. So we're just saying that the current position is a smooth movement, not a teleport from one value to the next, of a position A and a position B. Position A in your car is here. The position you want to go is here. And you're going to smoothly accelerate over this, those 2 positions, rather than just going from one immediately to the other. Okay, so we have that vector 3. Let's just say this transform equals, and I hate typing a whole lot, so I'm going to copy and paste it. And we're just saying this transform, which is the camera, equals this current position. This is being calculated on this line. Let's just say that this transform equals that position. Simple as that. That's the position. I'm going to hit save, Control S, and uh-oh. What do we got here? Cannot implicitly convert, so a type is wrong somewhere. Let's look it over. This transform. Oh, missed something. Duh. Not rotation. Oh, lordy. Okay. What we were missing was that. Good. Ugh. Mono development does some autocomplete crap. So this transform dot position, I didn't have that in there, equals the current position. So let's tell it that its position equals that. And then we hit save, and things are good. So let's hit play. We don't have a camera installed. See, nothing's drug in there. If I were to move our player, the camera's not following at all. It's not tracking its position at all. It's not a sign. But there's no error. Your game's not getting a red error and frozen up. If we were to remove this check, hit save, go in here, and we forgot to assign a transformer or player, we just got a null reference exception and the game is paused. Like it would not play. This would be a game crashing bug. I try to unpause it and it keeps telling me it's not assigned. Now, if it was made sure to be assigned and we hit play, we'd be good to go. Okay, it works. But that's why we do that sanity check. If that target is null and not there, don't do any of this moving to positions and checking positions. Alright, so we have the camera actually. Let's do this. Let's hit play. Let me I don't like the values we have. I'm actually just left mouse dragging. Okay, so I want to go with like 1 and -6. Let's hit play. And you're going to see if I move the player, the camera is actually following it. It's pretty darn cool. Let me increase the gizmo because you can't really. So the camera kind of smoothly follows it. Now it's jittering and jumbling just a little bit because I'm actually moving this box collider transform manually in the editor. That's normal. But if you smoothly move it with a movement script like we're going to set up, you won't see that. But look, it's tracking it, following it. It's pretty cool. And you can tweak the damping to be like, it's really having a hard time catching up. Like, it really lags. Or set it kind of high, those damping values, and it really sticks close. Like it can never get too far away from the camera. So position is working. Last thing in this script we need to work out is the rotation. So I'm going to remove some of these spaces, and we're going to comment in here. This is the stuff that is controlling the camera position in the world. Okay, and the next line down here, this, you know what, I don't like typing. Control C, rotation. So our next section here is going to deal with rotation. So we're going to type some stuff and I'll explain it in a minute. Quaternion wanted rotation equals quaternion look rotation target dot position minus, oh, I can't type, this transform position and hit that. Okay, quaternion. Basically, it's just Unity's way of representing rotations. So we're saying, well, this is the rotation we want for the camera. It is a type of quaternion. It would be helpful to look it up and hit enter. So it creates a rotation, what we're going to use here, which is quaternion. Actually, let's go back and just look at quaternion. They're used to represent rotations. Unity uses them internally to represent them. They are based on complex numbers and not easily understood. Normally you would just take existing rotations from the transform and use them to construct a new rotation to smoothly interpolate between two rotations. Well, that's what we're doing by using quaternion look rotation. Okay, so I'm going to explain it. And so we're saying we have a variable type. This is the rotation we want for our camera. It's a quaternion, which is the rotation right here in X, in Y, in Z. Okay? And it's going to equal a quaternion look rotation. And we're going to say, let's look at the rotations of, that's supposed to be a minus, that's a typo. The difference between where's the target, the player, where's the camera, the angle of rotation between them. And let's make sure we're only looking at the rotation from the target's, around the target's Y, around its, well, to visualize it, we only really want to look at its rotation around this y-axis in the quaternion, like this. How is it rotating like this? We don't care if the camera is like checking this. We actually want the player to be able to barrel roll and all kinds of crazy stuff. We want the player to be able to flip end over end like this and go upside down, and the camera not rotate upside down with it or rotate into a barrel roll. So the only one we're going to look at is transform up, which transform up in a vector 3 just means the y-axis. So the quaternion is saying this is the rotation we want for the camera. We're going to look at the rotation difference between the target, the player, and the camera itself around its y. Okay? And now we got to set it. By setting it, we just say this transform rotation. So this camera's rotation will equal that wanted rotation. Simple as that. Calculation occurs here. Actually applying it occurs here. And sometimes I like to hit a little enter in between there just to separate this so we can see this is the actual transform being applied and assigned. This is the actual transform's rotation, where they're applied. These are the calculations, these variable types. So let's hit save, and that should do it for this cool third-person camera follow script. And so we'll test it out and hit play, and we will move the player, and now you can see that rotation around the Y damping around it. Okay? And it damps up and down. And the player can flip up and down, and the camera follows always behind it. Cool, right? We don't get any weird gimbal locking or anything like that when you see what the camera's doing. Alright, I can also rotate like this, and see the camera stays upright and just follows it and lets the ship do its barrel roll. And like I said, 2 is probably a good default value. Because it actually, if the player slows down, he gets close, and if he starts to take off, he goes a little further away. If you don't want the camera to go so far away behind the player, then just bump the damping for position value up. This camera is a great asset for race car games, third-person shooter games, all kinds of games. It doesn't just apply to this, but this is our spaceship game. So let's go create folder. Not inside of the scripts folder, outside of it. And let's call it scenes. And then go file, save as, navigate to scenes, and we'll just call it tutorial. Okay? This just makes sure when we pick up here, video 2 is going to follow this one right behind it. I'll label it number 2 and put it in the playlist. And in the next video, we will set up the actual player ship to fly around and have full controls for throttle and braking and damping and just a really cool looking simulated physics. We're not actually going to use a physics setup, so this is great for mobile or anything purpose light. So next tutorial will be the player ship and its control itself. Now we have our Skybox, we have our camera that follows our player. So I'll see you in the next tutorial.